In my video, Revolutionizing Sustainability Disclosures with GPT-4, we discussed about how we can use Azure GPT-4 to extract information from sustainability disclosure standards. In this video, we'll see how we can convert that application into a Streamlit chatbot. Let's see how it's done. In the first step, we import all the packages. Importing OS to perform tasks like reading environment variables. Importing JSON because later on in the video, we will be downloading the conversation in JSON format. Importing OpenAI for availing their services. We have stored sensitive information like API key, API type, etc. in .env file. In this line, we are importing the load.env function from the .env module. .env helps us load environment variables from a .env file. Next, we import packages related to Streamlit and LangChain to work with chat messages, language models, document loading, embeddings, and conversational chains. The API key, base URL, API type, API version, and deployment name are all configured, ensuring the script can interact with OpenAI services seamlessly. Here, an instance of Azure Chat OpenAI is created. This is a part of LangChain package and connects with Azure Chat API. It's configured with the parameters we've extracted from environment variables, ensuring the chat model operates as intended. In these lines, an OpenAI embeddings instance is created. This object is responsible for generating embeddings, which are numerical representations of text. Moving forward, we are introducing a PDF loader to handle documents. A PyPDF loader instance is created to manage PDF files. It's initialized with PDF file name, which prepares it to load and split the document into smaller chunks. These lines execute load and split method of loader object. This method reads the PDF document and splits it into chunks, ready for further processing. We are using FAIS embeddings. FAIS is a library for efficient similarity search and clustering of dense vectors. Now we are setting the configuration for Streamlit app interface. This line of code uses the setPageConfig function from Streamlit. It sets the title of web page to DemoBot and even adds a favicon. A favicon is a small icon that is displayed on top of browser tabs. With the st.header function, we are displaying a header at the top of the app interface. This section gives information about the chatbot in the sidebar. Here we start by defining a system prompt. This prompt sets the stage for the chatbot, instructing it on how to interact with the users. It emphasizes that the chatbot should rely solely on the provided information without an external source. Now we create a seed message dictionary. This message is like the chatbot's introduction. It's flagged with role system to indicate that it's a system-generated message, and its content is set to our system prompt. This section deals with initializing the session state. We begin by checking if a key name generated is present in the st.sessionState dictionary. If not, we initialize it to an empty list. This is used to store the chatbot's responses or messages that it generates during the conversation. We then check for the past. Past is intended to store the user's previous messages or inputs. Similarly, we check for key messages and model name. Here, we are creating a clear conversation button in the sidebar. When clicked, it will clear the conversation history and reset session state variables. These lines of code execute when clear conversation button is clicked. They reset various session state variables, effectively clearing the conversation history and resetting the model name. This button downloads the conversation history as a JSON file. Next, we are setting up containers to display chat history and user input. Inside the container for text box, we are capturing user input and processing it. If there is user input, then we are performing a similarity search using the loaded document embeddings. We are searching for similar documents based on the user's input. Then we are creating a prompt that includes the system prompt, the retrieved documents, and the user's question. This information is being prepared for the chat model. Next, we are creating a chat message dictionary and appending it to messages list. This message combines the user's role, the content including the prompt, and appends it to the message history. We are using a conversational retrieval chain to generate responses. The question and chat history are passed in and the response is obtained. We are updating the session state. Finally, we are displaying the chat history and the responses. We are iterating through the generated responses and displaying the conversation in the interface. Let's check out the app. Let me start with a greeting. Awesome. The bot greets back and here is its response. Let's move on and give our query. There you go. The bot generates a response from the reference document. We can download this conversation by clicking on Download Conversation button. Here's how the downloaded file looks like. It's a JSON file. We can click the Clear Conversation button to clear the chat history and start a new conversation. There's a simple way to design a chatbot using Streamlit. Please try out and let me know your experience.